Hello. In this example, we're going to look at solving a system of linear equations, and we're going to focus on using the substitution method. So in math, because math is generally an algorithm, or especially in algebra, we're dealing with an algorithm, which is a series of steps. I like to write that algorithm or those steps out so you can follow it like a recipe. In this situation, our first step is going to be to isolate one variable. That's the main thing we want to focus on. We want to isolate one variable. It can be in either equation. It doesn't matter so long as you have x equals or y equals. So first step is to isolate a variable. Then, as the name implies, we will substitute that isolated equation into the other equation for its respective variable. So we're going to isolate and then substitute. At that point, we have one equation with one variable. We will solve. Once we get that, that will give us one of the variables, but we know that the solution to a system of linear equations is generally going to be an ordered pair. So in that regard, we need to plug that variable into either or both, if you want to be extra careful, of the original equations to find the other missing variable. And then, of course, we'll write our solution as an XY ordered pair. So the system we're dealing with here is x plus 2y equals 2 and 4x plus 4y equals 5. Now, we can use either the substitution or the elimination method, but we're going to use the substitution method here. So the substitution method is really useful when you have already a variable that is just x equals or y equals, when it's really easy to isolate a variable in one equation. So I'm going to take this top equation, and since I have x plus 2y equals 2, I'm just going to rearrange that and say x equals. And that would be 2 and subtracting the 2y to the other side. So x equals 2 minus 2y. So now I know what x is. X is equal to 2 minus 2y. I can plug that into my other equation for x. So my other equation, I have 4x plus 4y equals 5. Again, we want to sub that in there. So subbing that in is going to give me 4 times the quantity 2 minus 2y plus 4y equals 5. You'll notice that this resulting equation here only has one variable. It only has y in it. So we're going to be able to solve for y first. As I work through that, I'll distribute. That's 8 minus 8y plus 4y equals 5. So working through this, I'll combine like terms. That's 8 minus 4y equals 5. I will subtract 8 from both sides of the equation. I have negative 4y. 5 minus 8 gives me negative 3. And dividing by negative 4, I have y equals negative 3 over negative 4, which simplifies to 3/4. So what I have done is I solved for one of the variables. Now we need to take that y equals 3/4 and plug it into either or both of the equations from the start. I'm going to plug it in to x equals 2 minus 2y. So here I have x equals 2 minus 2. My y value we just found was 3/4. So x equals 2 minus 3/2. 2 is the same as 4/2. So 4/2 minus 3/2, we get that x equals 1/2. This is my solution. Now, we always want to make sure that we write our solution as an ordered pair. And the trick to an ordered pair is x comes first and y comes second. So you want to make sure that you write your X value first and your Y value second. And I'm just emphasizing that because we found, actually in this situation, we found X second. So I would be inclined to see students, or I would expect to see students write 3/4 and then 1/2, even though the answer is X equals 1/2 and my Y value is 3/4. So this is the solution to my system of linear equations. This is the ordered pair where both of these lines intersect. And of course, we can always come back up and check, plugging x and y into each of these equations. They will both give us a true statement. Right? So that's how we use the substitution method to solve a system of linear equations.